Hi everyone, a warm welcome to everyone for the EA Global Summit 2021. This is Mohammed from the organizing team. Okay, so before we start, as a part of an organizing team, I would like to thank everyone for your interest in joining for the session. So this session is all about the aspect-oriented modeling in Enterprise Architect, where the deeper insights will be shared by Fernando Pinciroli, who is the Chief Execution Officer of Sparx Systems, Argentina. So for your information, we will be muting all the participants throughout the session. And if there is any questions during the session or at the end of the thing, you can always use the chat window to drop your questions, and we will make sure we are covering it up at the end. Additionally, if you want to collaborate and communicate with Fernando, there will be like a dedicated Teams channel from the link in the chat box. You can always use that one and post the session an hour of time. Our speaker has agreed to stay in order to clear your queries. Okay, so we feel that that would be very comfortable for you. And if you have any difficulties in accessing the Teams link, please feel free to let us know in the chat box or just drop us an email at registration@eaglobalsummit.com. Okay, so thanks once again for your interest and support. And it's Fernando, the stage is yours.
Well, thank you very much for the presentation. I'll share my screen.
Yes, you can now.
Let me check if I'm options, camera. Let me check number. Well, let me please tell me if you can see my presentation.
Yes, I can see aspect-oriented modeling.
Excellent.
Yeah.
Well, hi everyone. Thank you very much for joining to my session. Today we will talk a little bit about aspect-oriented modeling in Enterprise Architect, but I'll start with some words about me. I'm CEO of Solus, Sparx Systems Argentina, sister company of Sparx Systems Australia, and we have been working with Enterprise Architect for more than 17 years ago. I'm PhD in computer science, consultant in software engineering and different areas, especially in Agile transformation. I'm working with one of the authors of the Agile Manifesto, delivering Agile transformation in the world. I'm working for a lot of time in more than 20 countries, in 3 continents, 4 languages. I'm also a researcher with more than 70 scientific articles published in Americas and Europe in journals and international conferences. I've delivered more than 350 courses and conferences. I'm a member of program committees and different international conferences, co-author of 3 books, and a reviewer of scientific journals, including NASA's journals. And the most important for me is I'm happily married with my nice wife, with 5 children and 7 grandchildren. I think this is the more important in my life. Well, I'll start with my presentation. We will talk about aspect-oriented software development. In order to understand the approach, we will continue with how to implement this approach in Enterprise Architect. We'll give some conclusions, and we'll check some references for those who want to read about this approach. Regarding aspect-oriented software development, I like to say that it's a new step in the only path that we have the evolution of software development. We need to manage software complexity, and this approach gives us the possibility to deal with cross-cutting concerns that are tangled and scattered throughout the whole software. This evolution comes from primitive data types passing to data structures, then to classes, and in this moment to aspects. In primitives, data types are char, integer, boolean, as you know. They were wrapped by the concept of a structure, but the very structure was wrapped again with the concept of abstract data type with classes, and the aspect is wrapping classes into this new concept. Well, this approach was created by Kick Sales, and the first aspect-oriented programming language is Aspect J, an extension of Java. Well, the problem, as I told you, is how to solve the scattering and tangling that we have in code. Imagine that we have different classes with different methods, and in these classes we have two kind of methods. Some methods that belong to the problem domain, and other methods that are not belonging to the problem domain. In general, they are called non-functional requirements or non-functional methods. In this case, we have these non-functional concerns or methods are tangled with the specific domain concerns. But they are not also tangled, but they are also scattered throughout the whole system. This problem of that we, in general, we call spaghetti code is solved by this approach, because aspect-oriented software development takes out these methods and encapsulate them into new elements called aspects. As you can see in the next slide, we have the previous classes without the scattered and tangled methods. These methods were encapsulated into new elements. These new elements are stereotyped as aspect. And the methods were taken out and put into these new elements called aspects. So in this case, in an aspect-oriented world, we will have classes and aspects. Well, of course, we have encapsulated all methods. We need to put them again in the original places because we are facing a unique system. Well, a weaver is in charge of connecting again the methods that we have taken out. We have the original class written in a regular object-oriented language. We have aspects. We need an aspect-oriented language to write this code. And as part of the aspect-oriented language, we have a weaver. The weaver must weave the methods in the aspect into the original places in order to compose a unique system. In enterprise architect, we will be indicating that some classes are aspect just with the stereotype. In this case, I was talking about non-functional methods, but we have also other kind of concerns, because, for instance, in the problem domain of a hotel, maybe we want to perform a hotel check-in, and the methods to perform this operation are scattered throughout all the classes or a lot of classes in the system. Maybe we want other kind of concern like hotel checkout, and we have methods throughout the different classes. These concerns must be encapsulated into aspects. But they are different because they are domain-specific aspects. So in this case, we will have aspects, including the classes that these aspects need to implement the objective of the aspect. But every class will have only the members, attributes, and methods that every class need to perform the objective of every aspect. You can see that maybe we will have the same class scattered throughout different aspects, but with different implementations. When in the moment of composing these classes, we have to merge the same class that it is presently in different aspects. So in an aspect-oriented world, we will have two concepts. We will have aspects. For instance, from my previous examples, we have the aspect error handling, security, and two aspects belonging to the problem domain, check-in and check-out. Every aspect includes different classes. In some cases, the same class could be present in different aspects. So we have aspects and classes. And well, we have to model all of this, but in some moment we have to compose all of this. How to compose this situation? Well, firstly, we have to compose the problem domain classes by merging the classes present in different aspects into a single composed class. And then the weaver is in charge of composing the methods of the cross-cutting concerns belonging to the non-functional requirements. This is the work that we have to do. Well, regarding the concepts or the elements of the aspect-oriented approach, firstly, we have the regular code that we have in our regular classes written in a regular object-oriented language. This is as usual. But we have to use an aspect-oriented language to write. For instance, this code is written in aspect J. We need an aspect-oriented language to write the aspect. And the aspect needs some elements. For instance, we have advices. Every advice is a piece of code that would be inserted in some point in the base code. In this case, we have two advices. You can see a before and an after advice. The before advice will be inserted before some point in the base code, and the after advice will be inserted after some point. This point is indicated by a point cut. The point cut has a condition indicating where this advice should be inserted. As you can see, this point cut is indicated by inversion of control, that some point in the regular code will be a join point. The base code doesn't know that it has a join point because this is indicated by the point cut. And of course, we need the weaver that will be weaving all the advices following what is indicated in the point cut in those join points in the whole system that matches with the text indicated in the join point. Well, these are the concepts. In this case, I have, after weaving these pieces of code, the base code and the aspect are woven. In this case, we can see the resulting code after weaving the base code and our aspect. Well, these are our elements, the concepts that we have to understand, well, to see how to implement aspect-oriented modeling into Enterprise Architect. Well, when we start with an aspect-oriented model in Enterprise Architect, we have to understand that we need to keep cross-cutting concerns separate throughout the whole system. So we need a mechanism in order to keep cross-cutting concerns separate. And then in every level of abstraction, in every level, we have to perform different and specific aspect-oriented activities, like we have to detect concern, we have to separate them, we have to encapsulate them, we have to indicate the relationships among elements, because we have to compose all the separated elements into composed ones. We have to include mechanisms to perform the composition, and maybe some functionalities to solve conflict that in some cases we can face after composition. Well, in Enterprise Architect, we will create all our level of abstraction in descending order as usual. For instance, in this case, I have a business model, user requirement model, software requirement model, maybe different views inside of some models. Well, this is as usual. We create all the level of abstraction that we need. After this, I'll enter the business model. And in the business model, we have to create both kinds of processes. Those processes that are concerned, but they are regular processes, and other processes that they are cross-cutting. And cross-cutting processes must be included into packages stereotyped with aspect. In general, we indicate aspects or concerns throughout the life cycle with packages. So every package in this moment is a concern. A regular process is a concern, and it is included in a regular package. But those cross-cutting processes are included in a cross-cutting package indicated with aspect. In this case, we are managing two approaches that we can find into the aspect-oriented approach. We have two lines, the symmetric approach and the asymmetric approach in the literature. In this case, we will have our processes as usual. So we have to manage them separately, those belonging to the product domain and those that they are cross-cutting concerns. In this case, in our process, we have a regular process. We have a point cut. The point cut is indicated by means of an annotation element from BPMN. The element must have a text following a specific grammar, because this grammar must be parsed in order to perform the composition. The aspect is indicated in order diagram. The aspect is indicated by means of a pool, and inside of an aspect we have the advices. The advices are allocated into lanes. In this case, we have two advices. The annotation element is the point cut, and the point cut is indicating the join point. In the advice, we have other element called join point, because it's representing all the join points in all the base processes that we have, indicating that they are join points. In this case, we have a before advice, because we have this activity register checkout before the join point. So this activity after composition will be composed before the join point in the base diagram. At the end of my presentation, I'll show you in Enterprise Architect a plugin performing this composition with an example. Well, all these conventions, the text, the grammar, the conventions, the elements that we are using should be selected from some approach. In this case, I'm using the approach that I presented in my PhD thesis, but there are different approaches in the literature that you can follow. Of course, I'm following mine. Well, we have all the packages. All the packages are containing the processes. We have base processes or base aspects, and we have a concern model. It is really easy for enterprise architect to parse the point cuts and to create this relationship between packages and indicating the crosscuts relationship among them. This is a traceability intra-level, but we have other kind of traceability inter-model. When we move from one model to the other one, to the next one, we have to copy all the package structure in the new model, because in this way, by using the same name, the same packages, we will keep separate all the concerns throughout the life cycle. Of course, it is possible to find, to detect new concerns in the following model, but we don't have to create it in the previous model, because all the concerns will be growing model by model. In this case, we will have, if we see both levels of abstraction, we'll have activities in the previous model, in the business model, requirements in the user requirement model, and the enterprise architect can trace requirements belonging to the same packages, because following the name of the packages can detect that some requirements must be traced with the activities of the previous model. But in case of aspects, we have to manually connect the requirements with the previous with the elements of the previous model. We have two kinds of relationship here: trace and crosscuts. In intra-level, in user requirements, we have different requirements. Some of them are cross-cutting requirements, and they will be connected via our crosscut connector with that requirement that they are cross-cutting. But regarding other kind of requirements, because this is modeled with functional requirements, with other kind of requirements, non-functional requirements, we have to follow the positive and negative contribution relationship that it exists among non-functional requirements that we can find in the literature. And it is possible to indicate that some requirement belongs to some category, and immediately will be connected with other due to this relationship that they have. When we want to move from the user requirement model to the software requirement model, again, we copy the same structure of packages. In this case, we will include a use case in every package to represent the concern. We are using the element use case, but the specification can be done by use cases methods, or you can specify them as user stories or wherever. But we use the element use case. In case of some concern is coarse-grained, we can slice it and maybe we will have more use cases in this model, but we must create a new package for every use case because every package is a concern. Maybe we can create a package for roles in this moment, or maybe we have previously created in the previous models. Well, after this, I like the use of use cases, the element use case, because they have a very good level of granularity because use cases are value oriented. I like the concept of role in actors and the concept of the extend relationship because, as you could see, in aspect-oriented software development, we have inversion of control, like extend is indicating. Perfect. In this case, when we move from functional view to the static view, again, we copy the same structure of packages, but in this case, for every use case, we have to create a collaboration. The collaboration will realize every use case, and the realization in this view will be a class diagram, realizing the use case. Then we will have different class diagrams for different use cases, and maybe, or it is really possible to have the same class repeated in different realizations. In this case, for instance, we have the realization of the concern number 1, the realization of concern number 2, and if we check, we can see sample protocol repeated in different concerns. Well, with our plugin, we must merge the repeated classes in order to obtain the composed model. In this case, we will have the classes that are repeated in different concerns included in the composed model as a single class, but including all the members, attributes, and methods from the original classes. And we must merge all the classes into a composed model. We have to compose attributes and methods. I'll show you how to do it. We have 3 approaches to compose: merge, override, and ad hoc. In case of merge, imagine that we have 2 classes in different concerns, and we want to compose these classes into a single one. In this case, since we are merging, we have the same method in both classes, and we move both methods, but we have to rename them. But we will create the method, the common method too. In this case, with a sequence diagram, I'm showing how to connect the original methods. So when we call receive sample, in this case, we will be performing both methods. One method of the original classes will be performed first, but if we want to indicate some order, we could use a relationship stereotyped with precedes in order to indicate that we want to have first the method coming from one concern and then the other. Regarding attributes, we can see that in the previous classes we have 2 attributes in one class, 2 in the other class, but when they are composed, we will have 3 attributes because code it is present in both original classes. In case of we have different types or different properties for an attribute, the final property will be the more the wider one, the wider one. That property that is covering both cases. In case that we use override instead of merging, we have to indicate that one concern overrides the other one. And in this case, in the moment of the composition, we will have in the compose class, in case of we have the same method in both original classes, we will have only one. The method present in the overriding concern. It's easier, but we are losing some methods. And ad hoc is a mixture of both previous approaches, because Enterprise Architect will be telling us that we have the same method in both classes, and we can choose if merging them or overriding them, or maybe avoiding the class, or for instance. Well, once we have merged the classes of belonging to the problem domain, we have to connect the cross-cutting concerns. And in this case, for instance, in this example, we need for the cross-cutting concerns parameterized packages in order to indicate the method that will enter the package, and then we have how to manage the methods. We'll have the entering method and the advice that will be added before or after, depending on the point cut, the entering method. Well, regarding the state view, we have state diagrams. In this case, we don't create a new view, because we put every state diagram depending on the class. And in this case, if we have the same class in different concerns, we will have two different state diagrams. In this example, for instance, we have one state diagram coming from one concern, and the other state diagram that when the classes are composed, we must compose not only members, attributes, and methods, but also the state diagrams. In this case, we will have a composed diagram including all the states from both original state diagrams. Well, just as conclusions, in this case, we can model in Enterprise Architect all the elements throughout the software development life cycle. Of course, that